let's take a look at the homework problem that I gave for today. Now, we did a bunch of different times. So if I make an example here, let's assume that I have 10 feet and it took 1 second to do it, and it took 0.9 seconds and 1.1 second and 1.2 seconds and 0.8 seconds to do the run with my little car, just like that. Okay, so in that case, what I need is a speed. So distance equals rate times time. The distance is 10, the rate I don't know, and the time is, well, I need to find the average of this time. So if I add all these up and I divide by 1, 2, 3, 4, 5, I come up with 10. No, I don't. 1, 2, 3, 4, 5. I come up with 5 divided by 5, and that equals 1. So I have an average of 1 second. So there we go, a distance of 10 feet and 1 second. So my rate is actually an average rate, and that rate is 10 feet per second. Now, what I need to do is I need to find the average rate, 10 feet per second, but that equals the linear velocity. So this equals V. V equals 10 feet per second. And if I want to find the angular velocity is omega. So I need to find omega. What is omega? Don't know, but I can say V equals omega R. Now, the interesting thing here is this is in 10 feet per second. So I'm going to plug it in, 10 feet per second. I don't know what omega is. I do know the radius because if I take my wheel and I measure, I go, oh, look, it's 2 inches wide, so the radius is 1. Radius is 1 inch. Now, I cannot put 1 inch in here because I have feet here. So what is 1 inch in terms of feet? It's 1/12 of a foot. At this point, I can solve for omega. Omega equals 120, and that's radians per second. Now, if I want revolutions per minute, I have to change radians per second into revolutions per minute. So 120 radians in 1 second. Well, let's see here. There are 60 seconds in a minute. And there are 2 pi radians in 1 revolution, and that should finish you up. So if you had a little trouble with today's stuff, none of this stuff is accurate, so you can't use it. But this will allow you to give an example to do what you were to do from in class. All right, thanks.